Thank you. So each of these modifications to our function are making our function translate. They're making it adjust. So we got to look at what each of those are doing and have those modifications modify the graph or the points that we're given. So let's, I want to start with the 8, -4. So 8, -4, let's say 8, -4 is right there. 8, -4. So any of the translations that occur inside the function are going to happen to our input value, so it's going to affect our x value. Any of the translations that happen after the function, so the +1 and the 1/2, are going to affect our outputs, so those are going to affect our y values. The strange thing, or at first strange thing, is that all of the translations that occur inside the function will always seem to happen in reverse. So this x minus 2, it might seem like that x minus 2 should send us in the negative direction, but it's not. It's going to send us in the positive direction. There's a couple ways to think about why that happens, but the one that I like is that this -2, because this -2 is happening before the function exists, it doesn't really move the function around. What it moves is the axes. It moves the x-axis. So if the x-axis moves -2, if this whole thing shifts that way 2 units, it's going to make whatever graph is on it look like it shifts in the positive direction. So everything's going to happen, everything on this inside. That's why, one of the reasons why all this stuff on the inside always seems to happen in reverse. So if we perform those modifications or perform those translations on this point, we're going to go this way 2 units because of this x minus 2. This 1/2 is going to take our outputs, our function values, so our y's, and stretch it, but it's going to stretch it by 1/2, which is actually visually going to squish it down. And that's going to go up 1. So the that way 2 is going to take this 8 and turn that 8 into a 10, because we're just going to add 2 to it. Again, opposite of what it says here. The -4 is going to be multiplied by 1/2. That's going to turn into a -2. And then we're going to add 1 to that -2, and it's going to be -1. So this point is going to land there. So the 8, -4 is going to turn into a 10, -1. And we're just going to do that same thing to these other points as well. So for the, say for this point at 0, 8, so 0, 8, it's going to do the same thing. It's going to go that way too. And then so it's going to land at 2, 8. Then the vertical stretch by 1/2 is going to move it down here to 2, 4. And then add 1 is going to shift it up just a little bit to 2, 5. So that point's going to land at 2, 5. This point, adding 2. So adding 2 is going to turn that to -10. And then 1/2 of 6 is 3 plus 1 is 4. The key is to focus on the idea that one of the keys is that the internal changes, the changes in here will only affect our x. So while we're doing these horizontal changes, the y value, nothing happens to it. As soon as we're done, our x value is done. When we go outside, that's changing our y value, and the x value is fixed. So find 3 points that are on the graph of the translation. Those 3 points. Does that help?
Yeah, I think I kind of get what you're going with here. It's confusing because the way that it's written down on here.
One of the big things that often gets people is they want the function. They want to see what the actual function is. And instead of being told the function, like told it's the square root of x or told it's x squared or whatever, all you're given is the 3 specific values.
Yeah.
But again, this what's happening in here is happening to that input, that 12, that negative 12. The values over here, well, that's after that took place, so that's those those changes. So it feels kind of like I'm not given the right information or enough information because all I have is these 3 points.
Yeah, because if it says y equals g of x and y equals f of x, so the confusing part is there's no like f of x here. Because f of x minus 2, I wasn't sure like what this really means.
Well, essentially, the function you're given, you are given a function. You're just not given an algebraically defined function. The function you're given is literally those 3 points. That is a perfectly well-defined function. It's just not algebraically defined, so it's awkward. It feels weird. You want to see an algebraically defined function.
So is this just basically saying like this f1/2 f of x minus 2 plus 1? So that's basically saying like insert like, so f of x over here 6 for negative 2 and then solve that point basically.
Essentially, yes. Where would, and we don't, and we want to know, okay, if we plug in that 6 for negative 2, where is this thing going to land?
Yeah, well, we'll plug in the 6 for x, I mean. Yeah.
Yeah.
So then it would just be like solve for x and then whatever that equals, then obviously y equals
right.
And that's, g of x.
And actually that's a really good way to think about it in some ways, that this x minus 2, the x minus 2 is going to be that 6. So the x minus 2 is going to be that 6. You said solve for. So that's a really good way to think about it, actually, because that's why, or one of the reasons why, we're, where is it? Oh, not the 6, sorry. For x. Backwards. It's like, so putting in this 8, that 8 isn't going into the x. That 8 is going in for the x minus 2. So what the function input was 8. Well, what's that going to turn into? Well, that's going to turn into a 10.
Yeah.
And that's why everything happens backwards on the inside, because you're kind of doing that solving step.
So I get that, right? So the 8, negative 4, you get the 10. Then, so how would, then from there, it says y equals g of x, and you just plug in your, say, your 10 or whatever value you get and solve for y, I guess.
Yeah. Essentially, so the y equals g of x is the 1/2 f at x minus 2 plus 1. So kind of like what you're saying, we know if we want to get at this negative 4, we'd have to plug in a 10. So the 10 minus 2 is going to be negative 4. And then the 1/2 times negative 4 plus 1, That's our half of -4 is -2 plus 1 is -1. And that's our -1.
Gotcha. So I don't know. I guess the whole wording on this just threw me off a little bit.
Yeah.
So that makes more sense.
Cool.
All right, I'll quit bothering everybody now with my nonsense.
You know, don't go there.
I had the same question, so I appreciate that you asked it.
Yeah, the whole thing, like once I looked at it initially on the handout, I was like, I have no clue what this is asking.
Yeah, same.
And oftentimes, instead of being given that question in, you have these points, give new points, you see the question written out actually this way as a table. And then you're given X and G of X, and you're asked to just fill this out given this relationship. And people often are like, I don't even know what this is asking me to do.
So if we encountered this like on a test, like, would you say the best thing to show our work would be to show the table, like write out the table like you did here with X and F of X, and then solve for each of the points?
Probably, yes, but I would tend not to see a problem like this on a test. For the test, you want to worry more about those problems that, not worry, but you want to be ready more for those problems like, okay, take a graph and, be able to move it around and do the stretching to it and be able to do the translations, or given one of the basic functions. So given x squared, you know what x squared looks like. Move x squared around, up, down, left, right, stretch it. Given absolute value of x, given the square root of x, those functions that we know what they look like, and then kind of, okay, what's the square root of x minus 4 going to look like? Well, it's going to look like this, but moved that way 4. What's 2 square root of x going to look like? Okay, it's going to look like this, but stretched upward. So being able to kind of define, hey, what are those translations actually doing to my graphs? Does that work?
Yeah.
Okay. What else you guys got this morning? This is kind of a day of answering questions, so questions are great today.
I don't know. I don't have anything else right now. That was just actually I got another thing I can think of.
Shoot.
So we're solving domain and range, right? Obviously, in most parabolas, domain is all real numbers.
Yes.
But for the range, like I was on the MyOpen Math yesterday doing an assignment, and I was like, I kept getting it backwards every single time. And so like I'm just confused on like when it's like your say your minimum is like -4. So how do you determine which way to order your range is my question.
It's a good question. Let me kind of back that question up a little bit, kind of turn into a full question just to kind of have us something to practice more fully. But I get that question, and we'll make sure it pops up here. Let's say -3. Okay, so we're given this quadratic. We should be able to determine a whole bunch of stuff. Y-intercepts, X-intercepts. We should be able to determine a vertex. We should be able to find domain. Though you're right, for quadratics, it's always all real numbers. And we should be able to determine a range. So we've talked through kind of most of these at one time or another. Our y-intercept is always going to happen when our x is equal to 0. So if we plugged in a 0 here, the 0x squared and the 5x would go away. We'd just be left with the -3. Do be careful with the idea that, oh, the y-intercept is always this constant on the end. That's a dangerous way to think about it because, for example, if we had something in vertex form, x plus, say, 3 squared minus 5, if we had something in vertex form and we wanted to, I don't know why I put an a there. Let's say that, I'll just let that a be 1. So if we wanted to find this thing's y-intercept and we said, oh, the constant on the end is a -5, so the y-intercept is at -5, it's not. We get the y-intercept by asking, well, what happens when that x is 0? Well, when that x is 0, we get, well, what, 3 squared is 9, 9 minus 5 is 4. So the y-intercept would be 0, 4, not this -5. So for the constant on the end to be guaranteed to be the y-intercept, we have to be in this kind of standard form of a quadratic. Because every other term has an x value in it, the zeros make them go away.
This
So,
can slice your hand open.
but be careful about
Don't
that.
touch my tools.
That's good advice. Don't touch daddy's tools. So be careful about that. That it's very common to have the y-intercept just be the constant on the end, but it's not always true depending on the form. So it is something to be careful about. For x-intercepts, similarly, we want the y value to be 0. So we're going to formally take this thing and set equal to 0. So I'm going to go off here somewhere and let 0 equal our x squared